Okay, so let's start. So in the last class we were talking about exception handling. That is where we have stopped, right? Yeah. So today we'll talk about finally block first. Finally block. Finally block. So what is finally block? Any idea about finally block? Okay. So now let's take this example. The code in the finally block would execute no matter what, after which only the program would end. Okay, I got another answer which I read now. So I can say that yes, finally block, it executes basically it executes no matter whether there is any exception or not. Finally block is always associated to a try block, and this finally block is always guaranteed to execute no matter whether there is any exception or not. Finally block is always guaranteed to execute whether there is any exception or not. Okay. So let's see why to use it. Now, if you people can recollect this code, you see what we are doing is basically we are trying to establish a connection here. We are trying to establish a connection. So once the connection is established successfully, once the connection is established successfully, you see this method, get connection method, it returns a connection object. And basically this connection object here, it represents a connection between the Java application and the database server. Okay, it represents a connection between the Java application and database server. Remember one thing, I'm not really trying to establish the connection here. You can think of it as a kind of pseudo code. You can think of it as a kind of pseudo code which I'm writing it here. Okay, yes. So, you know, this connection object, using this connection object, you'll perform some DB operations. Using this connection object, you perform some DB operations. DB operations means like adding a record, adding a record to the database server or deleting a record from the database server. It can be anything, okay? Some sort of DB operation, you can say. So once you're done interacting with the database server, you'll close the connection. It is highly recommended that you close the connection once you're done performing DB operation. How will you do that? This way, connection.close. So you know what, at this point of time, I don't want you people to worry about how to interact with the database server and all. That is not our main purpose. That is what not our aim. So our aim is to make you people understand how to work with this exception handling. So this example which we have taken here, it's related to exception handling. So now you see, it is highly recommended that you close the connection once you're done using it. Okay, yes. But you know what? I have a question at this point of time. Can I say that this connection or closing statement where it will execute here? Can I say that this connection closing code will always execute? Can I say that it will always execute? Is it guaranteed that this will always execute? Why so? Just a minute. So if the connection is not established, there would be an exception, okay? Fine. Or you see, for suppose if even after establishing the connection, if there is any exception here, if at all if there is any exception in line number 14 or 15, this code, connection closing code, will not execute, right? Yes. You see, this statement is not guaranteed to execute, right? So what I'll do is here, okay, let me use try catch. Even if you use try catch, still there is no guarantee that that connection closing statement will always execute. because if there is any exception before line 18, straight away the catch block will be called. Straight away the catch block will be invoked here. That is what happens. Okay, yes. So that means this is not the right place to write this code, because it is not guaranteed that the connection will be closed. Okay, the connection, there is no guarantee that this connection will close. The statement will execute. What to do? Use finally block. But this connection variable, it will not be visible in the finally block because it is declared in the try block. Make sure that you declare this connection variable outside of the try block, so that it is available or it is visible in the try block, catch, and finally as well. Okay, yeah. So that you see, if you declare that connection reference variable only in the try block, it will be only visible in the try block. It won't be visible in the catch or finally block. I want that catch, that final, that connection reference variable to be visible in try, catch, and finally. So make sure that you declare it outside of the try block this way. Okay. So now when I'm closing the connection, when I'm calling this close method, we are getting an error. What is this error? Just look at this error and tell me what is the issue here. Yes. So you'll find that here, this method, it throws a checked exception. This method, it throws a checked exception. So we need to handle it either using try catch or use throws clause. You have to use try catch or use throws clause. Okay. So here I'll use throws clause. I don't want to explicitly handle that exception here. I'll go for throws clause, throws SQL exception. So what does that means? Why do we use throws clause? In the last class I was talking about it, right? Why do we use throws clause? For handling, I guess it is there is a specific meaning for it. Throws clause. Just a minute, please. Just a minute. Yeah, I'm sorry. Okay, sorry. Yes. So throws clause here, it indicates that the process method process method it delegates the task of handling that SQL exception to the calling method. Whichever method is going to call this process method, that method will be responsible for handling this exception. Okay, yes. So you see here, this finally block, it is mandate, it is now guaranteed to execute. Whenever you're supposed to, whenever you have a requirement where you need to execute a task or any code mandatorily, whenever you got a requirement where you need to execute the code mandatorily, no matter whether there is any exception or not, then you can use finally block. Okay, and this is the order in which you'll write this try, catch, and finally. This is the order in which you'll write this try, catch, and finally blocks, I can say. Okay, this is the order of writing try, catch, and finally blocks. Yes. Okay, fine. Sorry. You know what? Here we can have a try without a catch also, but at least we should have finally block. We can do this. Try and finally. We can do this. We can do this. Try finally. Yeah, Praneeth, hi, no problem. Yeah. So I'm talking about finally block here. Yes, even others have just joined. People have just joined. I'm talking about finally block. So finally block is guaranteed to execute. Finally block is guaranteed to execute no matter whether there is any exception or not. Finally block is guaranteed to execute no matter whether there is any exception or not. Yes. Okay. Yes. So in this case, you see, we have to close a connection. It is mandatory to close the connection no matter whether there is any exception or not. Okay. Always we have to close the connection. So that's the reason why we use this finally block. Now you see we have try and catch, right? Can I say that we are handling the exception in this case? Can I say that we are handling the exception? We are not handling. Yes. In this method, process method, in this process method, we are not handling that exception. I can say just using this try catch. That's it. Try finally. So catch block is used to handle the exceptions basically. Okay, fine. I hope everyone got it. Finally block, you see whatever the code you write in the finally block, it is always guaranteed to execute, no matter whether there is any exception or not. It is always guaranteed to execute, whether there is an exception or not. If there is an exception, finally block executes. Even if there is no exception, finally block executes. In both the cases, it executes. So whenever you have to write any code which has to be executed mandatorily, you see Once you establish the connection, you have to close it. That is mandatory. So we use this final block. Yes. Fine. Now let's move on. So the next thing today we'll talk about exception. There is a superclass for exception, that is throwable. Throwable. So far, as we have discussed, that exception class is the superclass of all the classes in Java. Okay, exception class is superclass of all the exceptions here, right? But you know what? There is a superclass for exception also. There is a superclass for exception also. What is it? Throwable. Throwable is superclass of exception class. Okay. So when we talk about exceptions, exceptions are broadly classified into two types. Runtime exceptions means they are unchecked exceptions. Okay. Runtime exceptions and other exceptions. Runtime exceptions means they are all unchecked exceptions. You got unchecked exceptions. They are unchecked exceptions. Other than runtime exceptions, you see, all other exceptions other than runtime exceptions, they are checked exceptions, as we have discussed. Okay. Yes. Except runtime exception and its subtypes, all other exceptions are checked exceptions, right? If a given exception class is not a runtime exception class or it's a subtype, then you can call it as a checked exception. Yes. Okay. Now this is about exceptions. But for throwable, there is another class, subclass called as error. For throwable, there is another subclass called as error. So there are two subclasses for throwable. One is exception class, the other one is error class. So far as we have discussed, exception class, it represents the errors which occur at runtime, right? When I say exceptions, basically they are nothing but errors which occur at runtime. Exceptions are the errors which occur at runtime. Yes. What about error class then? We got error class, which is another class here. What about error class? So you people got any idea about error class? Yes. Is anyone familiar with error class? No? You know what? Here, Error class also represents the errors which occur at runtime. Exception class represents the errors which occur at runtime, right? Even the error class actually, it represents the errors which occur at runtime. Yeah, both exception and error class, they both represents the errors which occur at runtime. Then what is the difference between exceptions and errors? They both occur at runtime itself. Exceptions are those errors which occur at runtime. Errors also, they occur at runtime. Then what is the difference between exceptions and errors? I'll tell you people. Exceptions are those errors which we can handle. Exceptions are basically those errors which we can handle explicitly. So an application can handle this exceptions. So how do we handle the exceptions? Using try catch block. What about errors? Errors cannot be handled. Errors cannot be handled. Yes, once again I'm repeating. You know, errors also occur at runtime. I'm not talking about compile time errors. Errors also occur at runtime itself. Exceptions, they occur at runtime. Errors also occur at runtime. The major difference between exceptions and errors is errors cannot be handled, whereas exceptions can be handled. We can handle exceptions. Errors cannot be handled. Yes. Why we cannot handle errors? Let's see. Okay. We'll refer to the API once. Okay. We saw exception class hierarchy, right? Similarly, we got error class hierarchy also. Let's check this API once. You got this java.lang package. You see error summary. In the java.lang package itself, you'll find error summary. So you got this error class. So error, you see that highlighted statement now, that paragraph, just read it, you'll understand. Error is a subclass of throwable. It's a subclass of throwable that indicates serious problems, that indicates serious problems that a reasonable application should not try to catch. It indicates serious problems that a reasonable application should not try to catch. They are serious problems. An application should not try to catch this exceptions. Sorry, errors. Errors, your application cannot catch them. Yes. So, what are the serious problems here? Is let's see. We'll see that examples of errors. For example, this is best. You can easily understand this. You see, for error class, we got a subclass here. It is virtual machine error. This is one type of error, I can say. It is actually one type of error, virtual machine error. Okay, so virtual machine error means it indicates that there is some problem with your JVM. If at all, if there is any issue with the JVM, then basically you will see this error, virtual machine error. Okay, now this virtual machine error, can I say that it occurs in the application? Does this error occur in the application? No, right? So it's not that error did not occur in the application. Instead, it occurred in the JVM, the runtime system, I can say. So always your applications, you see, they run on top of virtual machine, the runtime system. So basically, a runtime system provides a platform. Runtime system provides a platform, or your virtual machine provides a platform for the Java applications to execute, right? And if there is any exception in your Java programs, you see they will be handled appropriately. If there is any try catch block, you see what the runtime system will do. It will call that catch block associated, appropriate catch block. Otherwise, what happens? Default exception handler will be called. Fine. So there is some problem with your application, but not with your virtual machine. Still, virtual machine has got no issues. Virtual machine has got no issues. So that means virtual machine will is working fine. So it will completely take care of this issue. That means exception. Either what it does, it will call the exception handler, that is catch block, or it will assign the task of handling the exception to the default handler. That's it. So you see, for suppose here, if at all if there is any issue in the virtual machine, at first place, if at all if there is any issue in the virtual machine, the virtual machine, will it be able to execute? So far we are talking about the errors in the Java application, which is running on top of virtual machine. But if at all if there is any issue with the virtual machine, then what? Who's there to handle it? What do you people think? Is there anyone to handle it? If at all, if there is any issue in the virtual machine, is there anyone to handle it? What do you people think? I can say no one. There's no one. Okay? No one can handle it. If at all if there is any issue in the virtual machine, then there's no one to handle it. So that means in that case the virtual machine will terminate abruptly in the middle of the execution itself. If the virtual machine terminates, if it stops execution, if it crashes, actually I can say it crashes basically. If the virtual machine is crashed, if it stops execution, is there any scope for the Java application to execute? Is there any scope for the Java application to execute? Is there any scope for the Java application to execute? There won't be any scope for the Java application to execute because you see the platform for executing the Java application is provided by the virtual machine. If that virtual machine has got problem, if that virtual machine itself is not executing, then there is no scope for the Java application to execute. You see, that means if there is any issue in the virtual machine, it crashes. and that means there's no scope for the Java application to execute. And if there is no scope for the Java application to execute, then how it can handle that exception? Will it be able to handle the exception? No, right? If there is no scope for the Java application to execute, how it can handle it? It cannot. So whenever there is an error, first of all, your JVM will crash, your applications will crash. There is nothing to execute. There's no one to handle this issues or error. Okay, so hope you people got it. And you see some other errors are internal error. You see these are different types of errors, which are subclasses of Java virtual machine. For example, we got this error here. What is it? Uh, Internal error. That means if at all if there is any problem in the virtual machine, okay, that is another error. Out of memory error. You see if the virtual machine if it runs out of memory, if it seriously runs out of memory, then that is also an error. You know, if the virtual machine runs out of memory, will it execute? I can say no, it won't. If the virtual machine, if it runs out of memory, then it cannot execute. It is not possible. It cannot execute. It is not possible. Okay. Stack overflow error, that is also related to memory issues itself. Next, we have unknown error. Okay. Miscellaneous errors, I can say. Miscellaneous errors. Hope you people got it. So, anyone got any questions in this regard, please let me know. Okay. So now you understood the difference between exception and error. Both exception and errors classes, they represent the errors which occur at runtime, but exceptions can be handled. An application can handle an exception, but it cannot handle errors. But it cannot handle errors, I can say. Okay, good. Next, what else is left over here? We got some exercises for you people. Just a minute. Just a minute. Okay, now just check this question, all of you. and answer this question. Okay, I'll mute myself just to answer this question. Yes, what is the answer? Okay, so I can say the answer is C. Yes, answer is C. How C? It's C. We have a class called as test. We got a class called as test. In this class, we have two methods. One is A method. The other one is main method. So from the main method, you see, we got a call to the A method. You see, this is your main method. Within the try catch block, we have this code. This method invocation is there. We got this method invocation within the try block. So now when that A method is called, what it does, okay, what is this throw new exception? Actually, so far you'll find that we have the that exception objects were created automatically whenever there was an exception. Whenever there is an exception object is created. Okay. Yes. But this time here we are explicitly creating an exception object, and then using the throw clause, it's not throws, it's throw. Using throw clause, we are delegating the task of, sorry, we are just handing over this exception object to runtime system. We are handing over this exception object to runtime system. Just a minute, please. Just a minute. Hello. Yeah, I'm sorry. So you'll find that this throw clause, it is not throws, it's throw. Why it is used? The throw clause is basically used to hand over the exception object to the runtime system. If you people remember in the last class, as I told you people, if at all if there is any exception or error in the program, what happens? Immediately an exception object is created, and the exception details are stored in that exception object, and then it is handed over to the runtime system. That exception object is handed over to the runtime system, right? Yes. You know, but we can also explicitly create an exception object and we can hand it off to the runtime system. So using the throw clause, we can hand over the exception object to runtime system. Okay. Yeah. Just a second, please. Yeah, I'm sorry guys. Now this statement, I will explain it here. We have used throws clause to delegate the task of handling the exception, right? But now what we can do is we can explicitly create an exception object of any type. We can explicitly create an exception object of any type. For suppose I can also do this runtime exception. I can add this throw. So what does that means? What exactly we are doing here? We are trying to raise an exception, produce an exception explicitly. We are trying to produce an exception explicitly. That is what we are trying to do here. Okay, we are producing an exception here. Okay, we are raising an exception explicitly. Yes. So we can do this, and then using the throw clause you can make a note of it. Using throw clause, we are handing over this exception object to the runtime system, or we are passing that exception object to the runtime system. Okay, using throw clause, we are handing over the exception object to the runtime system, or we can hand over the exception object to the runtime system. Throw clause, not throws. Yep. Here also, in this method, a method, when it is invoked, it is trying to produce the exception explicitly. I can say it is producing the exception, and after producing the exception, what happens now? That is, it is handed over to the runtime system. Runtime system, now it will search for the exception handler here. So do we have any exception handling code here? Do we have any exception handler? Can I say that in this method we have exception handler? No. Why no? Because there is no catch block. Though we have try block, but there is no catch block. That means there's no exception handler here. So what happens? Yes, the exception is not handled here. Okay, the exception is not handled. So what happens? First of all, finally block executes. It prints finally. Because the exception is not handled here, you see it will be delegated to the calling method. If, if the exception is not handled in this method, then what happens? It will be delegated, that exception handling task will be delegated to the calling method. Yes. So which method is calling the same method? Main method. So in the main method we have catch block, you see. So this catch block will be invoked, which prints exception. So after the catch block finishes execution, you see there is a statement after the catch block which also executes, which prints finished. That's it. So the answer is finally, exception, and finished. Answer is C. So hope everyone got it. So anyone got any issues or questions in this record, please let me know. Anyone got any issues or questions? Okay, good. Now let me show you people another question. Just a minute, please. I'm just checking for your question. Okay, this time the text size, font size will be little small. Please try to bear with me. So now you should see a question on your screens. Here it goes. Yeah. So just check this question, all of you. So just check this and tell me the output. Yes. What is the answer? Okay. I got a couple of answers. What about others? Okay, good. Yes, let's see. So here, as of now, in this test class, we got two methods. In the test class, we got two methods. One is foo, which takes an integer value. It's a static method, and we have a main method here. Yes. You know, in this class, test class, we got a static variable which is declared. It is of type string. It's a static variable which is of type string, I can say. So now from the main method, you see that foo method is called twice. From the main method, the foo method, it is called twice, two times. So each time, you know, that foo method is invoked. To that foo method, an integer value is passed. To that foo method, an integer value is passed. So for the first time, 0 is passed. When 0 is passed to this foo method, what happens? You say we have a try block. In the try block, we have this condition checking. If I value is 1, so we're checking for this condition. Is I value 1? I can say no, not at all. I value is not 1. So I value is 0. So if condition, there is a block associated to this if condition, it won't execute. Straight away the control comes to this line number 9, and you see which adds 1 to that output variable. It's a static variable, it is of type string. Initially there is nothing, just a, it's blank, that string is blank. So we are adding 1 to it. After this line number 9 executes, you see what happens. Okay, you have catch block, it won't execute because there was no exception. Finally block executes, which appends 3 to that 1. Already we have 1, it's a string, right? So it's a string. So when you add the string values, you see they'll be appended, that's it. So now they will not be, that arithmetic operation sum will not be performed here. After 1, 3 will be appended. After 3 again, you see this, you got the statement which executes, which appends 4. That means 1, 3, 4. That's it. So this is what happens for the first invocation here. This is what happens for the first invocation. That means when the foo method is called for the first time by passing 0, that is what happens. Again, foo method is called again, and you see that value 1 is passed. Foo method is called, it is invoked, and value 1 is passed. So this time that condition checking will be done. So condition becomes true this time, right? I value is 1. Because I value is 1, you see this exception will be raised. Exception is raised and that exception object is handed over to the runtime system. That exception object is handed over to the runtime system, I can say. Yes. Next, you'll find that the catch block will be invoked straight away, which will append 2 to that string. So 134, then it becomes 2. It appends 2. And after 2 is appended to 134, 1342, catch block executes. You have this return statement in the catch block. So what is the meaning of that return statement here? So what do you people think? What is the meaning of that return statement over there? So it indicates that the control should be written back to the calling method. The control has to be returned back to the calling method. That is what it indicates. Control should be returned back to the calling method. Okay. Yes. But you know what? You have a finally block. We have a finally block. Because we got a finally block, we'll find that it is guaranteed to execute. That finally block is guaranteed to execute, I can say. Okay. Always the finally block is guaranteed to execute. So it depends 3. So 1, first of all, you know what happens. 1, 3 and 4 is added. Next 2 is added. Now 3 will be appended. 1, 3, 4, 2, 3. So 3 will be added. And after the final block executes, simply the control is returned to the calling method. That means to the main method, the control will be returned back. To the main method, the control is returned. That is what happens. So the answer is 1, 3, 4 and 2, 3. Hope everyone got it. 1, 3, 4 and 2, 3. So any questions? Hope you people got it. For suppose, what if we don't have a return statement here? For the second time when you call foo method by passing 1, let's say there is no return statement, then what happens? What will be the output? If there is no return statement, then what will be the output? Shashi, you got the access to the Dropbox. I'm sorry, just a minute. Hi Shashi, did you get access to the Dropbox?
Um, Actually, what happened? You sent me the invitation, but accidentally I hit
Sorry,
the
just a
decline.
minute. Just yeah, now you can. Hello.
Yeah, you sent me the invitation, but accidentally I hit the decline. So right now I don't have access to the Dropbox.
Oh, okay. Okay. Send
Could
me.
you please send me one more time?
Yeah, just send me a reminder mail. Okay. Yes.
Yeah, sure, sure. Yeah, thank you.
Okay. No problem. So if return statement is added, if we don't have a return statement, then the answer will be 1, 3, 4, 2, 3, 4. Yes. So this our last output statement also would execute in that case. That's it. That would be the answer. That's it. Okay. So hope you people got it. Now, the last thing which I would like to talk about here today is regarding the custom exceptions. Custom exceptions. Custom exceptions. So, what do we mean by custom exceptions? What do we mean by custom exceptions? Custom exceptions. Custom exceptions means you can say that basically the exceptions which we need to handle explicitly. Custom exceptions are the exceptions which we need to handle, sorry, which we can define explicitly. Custom exceptions, we can define them. They are user-defined exceptions, I can say. You can also call them as user-defined exceptions. We can define our own exception classes. So far, what are all the exceptions which we saw? They are actually predefined. They are actually predefined classes, exception classes. Predefined exception classes. Now we can define our own exception classes. We can work with it. But now the question is, what is the purpose of custom exceptions or predefined, user-defined exceptions? Why we need user-defined exceptions? Yes. Can you give me a reason why we need to define our own exceptions? In what cases you would define you'll define your own exception classes? In what cases you will define your own exception classes? If there are any validations, then we can write custom exceptions. Okay. Okay. Fine. Good. So let's take this example. We'll consider this example the same second class. Here, you know what? We are checking for this condition. What is the condition? This withdrawal amount, it should be less than or equal to the balance. Withdrawal amount should be less than or equal to the balance. So if the withdrawal amount is more than the balance, then according to the business rules of the bank, according to the business rules of the bank, it is an error. According to the business rules of a bank, it is an error. as per the rules of the bank, it is an error. But according to Java application, can I say that it is an error? As per the programming is concerned, according to Java, is it an error? No, it is not an error. Yes. It is not a error. It is not an error. So because Java it doesn't identify it as an error, it won't identify it as an error. It's not an error for Java, according to Java. So there is no exception class for this error condition. There's no exception class for this error condition. As per the business rules of the bank, it is an error, right? So for this error, there is no, for this error condition, there is no exception class. But I would like to raise an exception when this error occurs. I would like to raise this exception. What to do? In this case, because there is no exception class for this error condition, Java doesn't identify it as an error, but as per the business rules of the bank, it's an error. We need to define our own exception class. Let's see how to define an exception class. I will define an exception class with this name. Insufficient funds exception. Insufficient funds exception. Now, this class which you got here, it is a normal Java class. It's just a normal Java class. You know what? Java, it's just a normal Java class, nothing more than that. Now, how do we make it an exception class? How do we make it an exception class? You have to make sure that you make this class extends exception class. Make this class extends exception class. That's it. Now it is an exception class. I have another question. This exception class, is it a checked exception or unchecked exception? Okay. I gave you the definitions for checked and unchecked exceptions, right? When we say checked exception, what does that mean? Checked exception means it is either, sorry, checked exception means an exception class which is not a runtime exception or a subclass of runtime exception. If an exception class is not a runtime exception class or a subtype of runtime exception class, then it is a checked exception. Okay. So exception class, is it a runtime exception class? Can I say that this is a runtime exception class? No. Exception class is not a runtime exception class, or it is not even a subclass of runtime exception. That means definitely this class is a checked exception. If this exception class is a runtime exception or a subtype of runtime exception class, then you can say that it's an unchecked exception. But this exception class is a checked exception class. This exception class is a checked exception class. Okay. So now, whenever this error occurs, what is that error? If user tries to withdraw more than what they got in their account, if user tries to withdraw, if user is trying to withdraw more than what they got in their account, then you know I would like to raise that exception. How will you do that? So first we need to create that exception class object, insufficient funds exception, and then I would like to hand over this exception object to the runtime system. I would like to hand over that exception object to the runtime system. How can we hand over this exception object to the runtime system? Throw. Use throw clause. Yes, that's it. Use throw clause. So whatever the exception object which we are creating here, it is handed over to the runtime system. That is what we are doing. Now there is an error. What is the error? Can you people tell me? What is the error here? Yes. What we are supposed to do? this method, it throws a checked exception, right? This method actually, it throws a checked exception. So either we need to handle this exception using try catch, or what is the other option we have? You can use try catch to explicitly handle this exception, or use throws. I would like to go for throws. I want the calling methods to handle this exception. I want, I want those methods which invoke this method to handle that exceptions. Whichever method invokes this method, that method is supposed to handle it. I'll do this throws insufficient funds exception. So I'll add this. So now you'll find that again we got an error. Why we got an error? This is different. There is an issue with the method signature, especially we are implementing. If you people remember, the savings account class is implementing that I account service interface. So this withdraw method is defined in the interface, and savings account class is implementing this method. It is overriding this method from that interface. So in the interface we have this withdraw method. So that savings account class is implementing it. You see, that means overriding it, I can say. When it is overriding, originally this method, how it is defined in the interface, do we have any throws clause here? Do we have any throws clause here? No. For this method here, you see, the method which is defined in that interface, originally for that method there is no throws clause. Throws exceptions list, we don't have anything for this method. But when the savings account class is implementing this method, it is adding this throws class. That means when it is overriding, it is additionally adding this throws class. Is it allowed? No, that is not allowed. So make sure that you add this throws insufficient funds to the interface itself here. We add it to the interface itself. It is better to add it here also for this method, throws insufficient funds. So while overriding this method, the subclasses will make sure that they use this throws insufficient funds exception. They can use it now. Otherwise, they cannot use it. If the for the superclass method, if there is no throws list, then you can add it. We cannot use it for the subclass. The subclass, while overriding that superclass method, it can use the same throws list, or instead it can just avoid it, but it cannot add the throws list additionally here. Subclass cannot add throws list additionally if for the superclass method if there is no throws list. So hope you people got it. Can I have yes? Okay, good. So Now, this is about the exceptions here. This is about the exceptions. With this, I'll close this exceptions concept. With this, we'll close this exceptions concept and we'll move on. The next topic which we are going to discuss here will be regarding the IO streams. IO streams. IO means input output streams, I can say. Input output streams. So, what do you people know about IO streams? Can you people tell me what are IO streams? What are IO streams? No idea. Okay. You'll find that streams they are used to transmit the data from a source to a destination. IO streams are used as channels to transmit the data from a source to the destination, I can say. So if you want to move the data, if you want to move the data from one place to another place, if you want to move the data from a source means where exactly the data originates. Source means where the data is generated or where the data is produced or it originates, to the destination. Destination means where this data, it has to be moved to which place, that is the destination. A source can be a file, a buffer. A source can be an application which produces some data, or a network socket. Source can be anything which has got some data, which produces data or which holds that data. Next, we got destination. Destination can be again a file. Sometimes we write the data to the file, or we save it to a buffer, or we send it across the network through the network sockets. Depends. So what is, like, we'll take an example to make you people understand how we're going to use the streams. Okay. Yes. So first, suppose, let's say you got a requirement, you have a file, you got a file, and you need to read the data from the file. So how to read the data? Through a Java application. We got a Java application. So through the Java application, you're supposed to read the data from the file. Through the Java application, you're supposed to read the data from the file. Okay, file can be anywhere on your file system. So we have to read the data from that file. How can we do that? Now we need a medium to transmit this data from the file to the Java application. We have to move the data from the file to the Java application. We need a medium here for that. That is where your streams comes into the picture. We can create a channel or a stream, I can say. We can create a channel or a stream here, which we can use to move the data from the file into the Java application. You know what? This channel, which is used to move the data, is called as a stream. Why we call it as a stream? Because this channel, it represents that moving data, the data which is moved from one place to another place. We say the data will flow through this channel. The flow of data this through the channel, we refer to it as a stream. We refer to it as a stream. Stream means, in general, the meaning of stream, flow of something, right? Here, this channel, we are using it to move the data. That means the data will flow through the file, or from the file to the Java application, will flow into the Java application from the file. So this is a stream which represents flow of data. Data flows from the file to the Java application. So this is a input stream. Again, see, streams are directional. I'll talk about it. As of now, this stream, I can say that it's an input stream. Now the question is, how can we create this stream so that we can use it to read or to move the data or to flow the data from the file into the application? Let's see. So before that, first of all, let me show you people a file here. You see, I got a file with the name data.txt. It is in C drive test folder. Under the C drive, I got a folder called as test. In that folder, I have a data file, text file. I want to read the data from this file. I would like to read the data from this file. So how will you do this? Let's see. First of all, I'll create another Java project for this. Let me create another Java project. Java proj. Sorry, IOproj. Okay. And here, you know what? Now we have to create the stream. Just a second. So how do we create a stream, that input stream? So this is where we are going to use a package called as java.io. This is where we'll use a package called as java.io. In this package, we have a class called as file reader. This file reader class, it represents the input stream which is used to read the data from the file. That's it. Okay. Okay. Now we'll use that file reader class to create that input stream. We'll define a class called as test. We'll add a main method. File reader. I'll instantiate this file reader class and we'll pass that location test slash data.txt. You know what? Here we are passing the complete path. In the C drive, we have a folder called as test. In that folder, we have a file with the name data.txt. So we are passing this path to the file reader class constructor. It's a constructor, right? So we are passing it to the parameterized constructor of the file reader class. So we are instantiating this class, file reader class. You know what? Here, this file reader object, it represents file reader object represents what? What it represents? Input stream. Okay, we are getting an error. Let's see. Now you people know this. You have to tell me. Just check, read this highlighted message. I'm sorry. Just a minute, please. Just a minute. Yeah, I'm sorry. Yes. So why we are, how to handle this error? Yeah, how to handle this error? It's an error, right? Actually, this constructor also throws an exception. Can a constructor throw an exception? Of course. Constructor is also a method. It's a special method, as I told you people. Sorry. Constructor is also a special method. Okay. Constructor is also a special method. So now either you can use try catch or use throws. I'll use throws. So what is the exception which it throws? File not found exception. Yeah. Now we got this file reader object which represents that stream. So once you got this stream, now what you can do here, you can use it to read the data from the file. We can use it to read the data from the file. So how can we read the data from the file using this file reader object? Let's see. Here we got a method defined in the file reader class. We got a predefined method called as read. You have to call this method. Read method, you know what it does? It will read a character. So it reads a character. When you call the read method, you see, for the first time if you call the read method, it reads the first character from the file. It reads the first character from the file and returns the Unicode value of that character. It returns the Unicode value of that character. Okay. You know, yes, Unicode value is integer type value. What it said, the read method will read the character. But the first time if you call the read method, it reads the first character. Okay. And what it does, it returns the Unicode value of that character. Unicode value is what type? It is integer type, numeric value. Okay, but it also throws an exception. It throws an IO exception, which is a super type of all the IO exceptions. Okay. Now you see that integer value which you got here, it represents a Unicode value of the character. But you see, we are only reading one character. How do we know how many characters we got in that file? You have to read all the characters, right? So how many times you have to call this read method? How will you know that? So actually, there is no method to find out how many characters we have. We can't count it. Okay. But what we can do is here, we can use that read method itself. Read method, whenever it reaches end of file, it returns -1. Read method, whenever it reaches end of file, it returns -1. Okay. That means we have to call that read method till it returns -1. Once read method reaches end of file, it returns -1. I'll check this condition. If I not equal to -1, what we'll do here, we'll take that Unicode value and we'll convert it into character type, and then I'll print it. I'll use print method to print that character. After printing that character, I'll read the next character here. I'll call the read method, file reader dot read method. That's it. Okay. So how it works, you see this while loop, how many times it iterates? What do you people think? This while loop, how many times it iterates? Yeah, this while loop will iterate till that read method returns -1. Okay, till it returns -1. So That is what happens here. Okay. Yep. So when it returns -1, when it reaches end of file, when it reaches end of file. So this while loop will continuously execute till that read method returns -1. Okay. Hope you people got it. Fine. Now, once you're done reading that characters from the file, or you're reading the data from the file, you can close it. You can close it. Yes. Okay. So we'll run this code once. We'll test it. Okay. That's it. So is it clear for you people, all of you? Okay, good. Once I'll quickly review this. Okay, I'll explain it once. So first of all, here you see what we are doing is we are creating a stream, input stream, and then here we'll use that stream. That stream refers to that file, right? From Java application, we have opened a stream to that file. Now we'll use that stream to call this read method, which will help us to read the data from the file. Each time you call the read method, it reads only one character. For the first time, if you call read method, it reads first character. For the second time, it reads second character. For the third time, it reads third character, and so on like this. Okay. Yes. So we are reading the first character, and then we are checking whether it is -1. If it is -1, what does that means? That means we have reached end of file. For the first time itself, if you get -1, that means there is no data. There is no data. Otherwise, if it is not -1, that means you got some data, some character. You can convert it. You can print it. After reading that first character and printing it, Again call the read method. You'll get another character. You can check whether it is -1. If not, you convert it, you print it, and this process will repeat. That's it. This is how you can read the data. Next, you know what, here reading the data character by character could be uneasy, right? Reading the data character by character is uneasy. So what to do then? We can read a line at once. We can read a line at once. For suppose, let's say you have this data. The 4 lines. Okay, in that file we got 4 lines. Let's see how to read this data. This time we'll do one thing. We'll use buffered reader. You know, file reader will not help you. Of course, we need this stream to transmit the data, but we'll add a buffer here. This way, buffered reader is. What is this buffered reader? With the help of this buffered reader class, I can say that we are attaching a buffer. We are attaching a buffer, I can say. Yes. What is a buffer? What do we mean by buffer? Yes. Buffer means, yes, a temporary memory. Buffer refers to temporary memory. So you see, to this buffer reader class constructor, we are passing that file reader object. That means that input string. Now all the data from that buffered reader, sorry, all the data from that file, all the data from that file will be read into a buffer, and it will be stored in that buffer. Now we can read the data from that buffer using that buffered reader methods. Buffer reader class provides methods. We are simply dumping all the data from the file into a buffer, okay, and then we'll use buffer reader methods to read the data. You see, in the buffered reader we got this methods, buffer reader dot read line. We can read a line at once. If you call this read line method straight away, you'll get a string object reference which refers to that line. For the first time, If you call read method, you'll get the first line. Again you call the read method, you'll get the second line. Again you call the read method, you'll get the third line, and so on like that. Okay, yes, that is how it works. So now how many times we have to call this read line method? How many times we have to call this read line method? No, now we know the number, but let's say we didn't see that file. We don't know how many lines we have. Okay. In that case, you see that read line method, what it does is basically it returns null if it reaches end of file. Read line method, it returns null if we reach end of file. Okay. Read line method returns null if it reaches end of file. So that means I'll do this str not equal to null. I'll call the read line method continuously till it returns null. I can say str equal to print it, and then we'll read the next line, buffer read line. That's it. We'll close the buffer, we'll close the stream. Okay, so first time we'll read that line. It returns that line by storing it into a string object. That line will be stored into a string object, and that string object reference is written. So we are checking if it is null. If it is not null, whether it is not null, it should be not null. If it is not null, that means we got a line. So if it is a line, we'll print it, and then we'll read next line by calling read line method again. And then you see here, after reading that line, again we'll check whether it is not null. That means whether we have reached end of file. If it is not end of file, again we'll print it. If it is not end of file, again we'll print it. After printing it, again we'll read next line. Again we'll check whether we have reached end of file. If not, again we'll read next line, and this will continue. Yes. Till that read line method returns null. This will continue till the read line method returns null, I can say. That's it. That is how it works. Okay, let me run this code. See, we got that content. This is how we can read the data. So hope you people got it. Any questions? Fine. If it is clear, then I'll stop it here today. One important announcement: there is no class tomorrow. Day after tomorrow, I'll take the class. Maybe only for 1 hour. Okay. Actually, um, day after tomorrow, yeah, we'll start at same time, but I'll take 1 hour session. Okay. Yeah, tomorrow I'm not available. Tomorrow there is no class. Again, we'll meet day after tomorrow. Okay. Yeah. Yes, Shashi, tell me. Any doubts, Shashi? Can you do one thing, please? Just drop me a mail, okay? Just drop me a mail, okay? Yeah. Okay then. Thank you all. Bye bye.